Welcome back. In this video, we will start to study TensorFlow, the deep learning framework. It is very popular. Many deep learning engineers prefer to use it. Let's see some information about it. TensorFlow is a Google second generation software library and for data flows programming. It supports the various deep learning algorithms as well as the computing platforms. Its system stability is very high. What is more important, it is open source, so it is easy for users to maintain, update, and improve the development efficiency. It can be used for machine learning across various perception and language understanding tasks. We can see TensorFlow ranked top 1 on GitHub. Why it's so welcome for engineers? That's because its characteristics. Let's see some characteristics of the TensorFlow. There are 6 characteristics. TensorFlow can run on different computers, ranging from smartphones to the computer's clusters. It is flexible and scalable. For multi-languages, it supports C++ and Python, Java, and so on. When we use our computers, TensorFlow can allows automatic selection of the CPUs or GPUs according to the machine's configurations. That is more user-friendly and intelligent. You can use it to quickly generate your training models on various dies on your Mac, Linux, and Windows operating system. So it is across the platforms. That's what we call right of the box. TensorFlow used the DAG diagrams to create the workflow and diagrams that optimized the computing processing, so it has powerful computing capabilities. As the model becomes more and more complex, the parameters get more and more. Distributed computing can support multi-GPUs working at the same time. It greatly improves computing power. It can apply to many fields, such as self-driving car, image recognition, language models, automatic story programming, and music creating, speech recognition, human activities recognition, and games, and managed applications, and used TensorFlow. And note that image recognition is much more mature. You can use it to generate various interesting pictures, transfer some pictures into the artist styles, and it also can detect people's age. For example, it can recognize the boy is 6 and the man is 51. We introduced the overview of its characters. Let's see how it works. What's the TensorFlow? As its name suggests, it consists of 2 parts, tensor and flow. Tensor is the carrier of the data, and we can decide that it is a multidimensional matrix. And we all know the scale and vector, so scalar is the one-dimensional and vector is two-dimensional, so the TensorFlow is the multi-dimensional. We can represent multi-dimensional data with tensor, and flow is the describe of data transmissions, just like the data flow diagrams. For example, z equal to x multiplies the y, and we do the multiplication, and first we should to transfer the x value and y value into the tensor and give the master. The master will return our result and 72 and give the result to the tensor. That's the flow, and we will get the result. So we need to, in the tensor flow, we need to the functions and run the z and to calculate the result. That's the data flow graph. The basics data flow graph. The process from the x, y to z is the flow. So how does TensorFlow works? Let's see the image. There are nodes and image and each
The nodes are the operations. They are such like the images, the multiplies, and pairs add. There's many operations, and age is the flow root, and root to update the weights, update the bias. It describes the relationship between the nodes and use the edges. And data in the TensorFlow to another node to do computation. It's just like the water is flowing in the river. TensorFlow describes our deep learning or machine learning algorithms in the graphics ways. We call the graph is a computing graph. The computing graph is the core part in deep learning development. It is the architecture of TensorFlow. TensorFlow's architecture is layer by layers. As the image shows, the architecture contains the two parts, and the front part and the back part. The back part is the core library, and the core library is based on C++, and it is efficient. We can use it in the Mac, Linux, Windows, and these computer systems. Its kernel uses the isolated heterogeneous code, so it supports the basics machine learning algorithms such as CNN, IN, and so on. The bottom layers of the core library is the network layers and the device layer. And it's very easy to use because it supports various languages such as C++, and Python, and so on. And also have the Python last line, and the training have the very many kinds of the training libraries. And there is the C APIs to isolate silent code and the TF core libraries. This makes the two parts work efficiently. Here are a few basic concepts of TensorFlow. They are tensor, session, graph. Graph encodes the node edge, session uses the feed factors and operation variables. So we will explain them one by one. First, we introduce the tensor. We have already said it before. The tensor is the data scratch in TensorFlow. Tensor is the n-dimensional, and in the computing graph, the tensors are the data that follows between the nodes. The data scratch contains in a tensor, and the scratch is just like that, name, address, shape, and it's the type. So next is computing the graph. It is also called the data flow graphs, and it is the expressions of the algorithms as the image shows. A node in the graph is and a node is a sort, and you can input and multiples, and you can add is the operations. And one node can get data from the one or multi nodes. You can input the 5 and 3 is numbers and to do the operations, and it can pass the result to another node and to other nodes. It just describes the input or output relationship between the nodes like that. It can describe the input or output. It can give the nodes the values, then given the list as 3 values, and to describe the relationship between the nodes. It can this is the simple graph. This page shows the mainstream operations in TensorFlow, such as elemental. The element is wise the matrix operations, metrics such as add, sub, divide, expression, and log, greater, less, equals, many basics mathematics operations. And other important operations, the array operations, the matrix operations, diff or matrices, and we will use them in the later experiment. So if you use it, you can search these operations and practice them. And next we like to take a look at assessing. When we run a TensorFlow graph, assessing owns and manage all resources. So it is very important for TensorFlow. Client use assessing to interact with the TensorFlow systems, generally it has the two following steps. First, create a stacing and an empty graph will be generated. As the image shows, we can add a lot of the operations to the libraries, the biased weight and the vector x. So this the node is the operation add a mutate and values this action activation functions. In the simple setting, this means the wx address the bias this formula, and we can use the run section as the system point run to obtain the operation result. You want to know all the parts you want to calculate, and setting is a statement that TensorFlow execute to control and output our files. So how we should to input the data to assessing? Here I introduce the feed injections mechanism. The feed mechanism directly contains the tensor to a node in a graph, and it temporarily replaces the tensor value on the node. A feed is not created when the graph is formed. It is applied when the graph exclusion is triggered, and that is, the feed data is used in the form of parameters when the run and the evolved command is excluded. After the exclusion is complete, the replaced data will disappear, but the operation we add in the graph doesn't not change. Generally, the feed mechanism is used together with placeholders, these functions. After learning the input data, in this page we will learn how to get the data. The fetch mechanism retrieves the result and operations in a graph. When the graph's exclusion is triggered, the factor application occurs. It doesn't occur when the graph is generated. If we want to fetch the tensor value of the one or more nodes, we can call the run method on the sensing object. And we can also use the list of the nodes to be factored as parameters to exclude the graph. Next, the concept is a variable. A variable maintains the status information during graph exclusion. For example, in the neural networks, it is used to identify the coefficient such as the W and B is the weight and bias. The variables in TensorFlow is actually a variables object in Python. When we instance a variables of the TensorFlow, we can set it to a random numbers, constant, a number of the calculated based on the instance value of the other variables. Note that because the bottom framework is written by C++ language, so we need to declare variables types before we use it. Now we have the general impressions of the TensorFlow. Let's see the modules of it. Here are some common modules of TensorFlow: TF support and TF.NN, TF byte-wise, the compact and contrib and estimators and errors. And let's learn the TF.NN. It is the most commonly used modules for construction classification convolutional networks. And it includes sub-modules, run cells, and it is used to construct recurrent neural networks. And let's see some application of the estimators. And it can be used to create one or more functions and define the features columns of the model. It also can instantiate estimators to define the features columns and various types of the hyperparameters. It call one or more methods on estimator object and pass the operator's input functions as the data source. And now let's see the advantage of it. Estimator-based models can run on the single service. Also, it can run on multiple distributed services without the need for the modification. This can save a lot of time and improve the efficiency, and the estimator is usually simpler than using a low-level APIs. And TF layers as encapsulate the variables and the operations. For example, the full connector layers performs a weighted sum operation on the input and used an operational activation function. The weight and the bias are managed by the TF point layers, this method. The last one is the TF contribution, and this module provides the functions for computing streaming matrix. It is the sub-module Slim is the most commonly used in these modules. It has many functional sub-modules and encodes all the experiments or easy to change the model. Abreast TF pointer contribute provides the advanced operation for computing layers in the calculation layers, such as regularization, summarized operations, and calculations. Okay, now we learned some basics modules in TensorFlow. Let's get how to use the TensorFlow, and we could introduce the forms its setup. In the previous courses, we mentioned the TensorFlow is the course platform. Now we can see it can install on Windows, Mac, and Linux computer systems. Let's see how to install TensorFlow step by step on Windows. First, we should install the Python 3 software. Then we enter the command product cmd, and cmd is cmd command prompt. We enter the command prompt, and there are 3 methods to install the TensorFlow. If you use the pip, this command, and install the TF nightly, it will install the development library. If you want to install the addition of TensorFlow, you can choose the pip install the TensorFlow. This is the command. And if you have already downloaded the package, you can install the Office line and under the package, and you can install it. If you want to install the GPU version, follow these steps. Install the CUDA software package and install the cool DN libraries. And also these are 2 needs to match with the TensorFlow versions, and the tester graphic card, and then run the NVIDIA CMOS command to view the graphics card information, and then check the CUDA versions. Let's see how to install the TensorFlow environment on our Mac systems. Mac systems, I recommend to install the home boost first, and then run the blue install Python command. You can search for tutorials online, and you can use the Python in home boost to install TensorFlow. Another method to install TensorFlow is the virtual environment. You can get tutorials online too, and cause the Mac system doesn't support NVIDIA the graphic card, so you just can install the CPU version TensorFlow. So only CPU is supported on your Mac computers. And setting the environment and Linux is the easiest. Just install directly with the pip, this command. And all operations are sourced in the major. There is a problem the testing version 2 is true. If you want to use the Python 3, you can get the tutorials online, and you can search something, and you can just to use the pip installed is the website address, and if you want to install the GPU's version, you can use that, and this is the GPU's advanced libraries on this website. You can use the pip install this version, GPU version. This is the simple running TensorFlow's example. And first we should enter the Python environment, then we should import the TensorFlow modules and TensorFlow. Then we should define a TensorFlow constant named hello and named hello TensorFlow, and defined a TensorFlow session named session ses, and then we run the tensor, use the session pointer run. Now fetch the values of the hello and print it. Finally, we will get a result 42. That's the whole process of the running TensorFlow. And first, you should initialize the variables and declare variables types, and then you should use, if you want to run the TensorFlow, you should use the session point run this method.
After we set up TensorFlow environment, we can use it and build the deep learning models. And in next video, we will introduce how to use it. Okay, see you in the next video. Bye.